Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2018 Specialist Maths Exam 1 for the Northern Hemisphere. Like always guys, before I start this video, if you guys want private tutoring in Specialist Methods, Physics or Chemistry, you can always email me through this email. Guys, we also have an announcement to make. We just currently launched our website, and in this website, we're pretty much selling notes. For example, we've currently put some physics notes for the new study design. I've pretty much written them, and they are very comprehensive and detailed, and they are very cheap. If you guys want to check them out, you can always go to the website. It'll be in the link in the description anyway. We are also putting some practice papers in there. For example, we currently have right now some physics practice papers, and hopefully in the future we can put some chemistry, specialists and methods, and we want to make sure that they are currently like the same as VCA. So currently similar in terms of difficulty, so a lot of students can practice. And yeah, that's hopefully in the future. Currently we have some physics ones, and if you guys want to check them out, please go have a look. And yeah, let's start this video. Question 1. A light inextensible string hangs over a frictionless pulley connecting a masses of 3 kg and 7 kg, as shown below. Draw all the forces acting on the two masses on the diagram. Okay, not too bad. So what we're going to do, we're going to have, for all masses, of course, we're going to have a gravitational force. For example, for the 7 kg one, we're going to have a 7g going down. And for the 3 kg, we're always going to have 3g going down. So, okay. Also, because we're using a rope, there is going to be tension force. And this tension force are going to be equal because they are acting in the same rope. So the tension forces are going to be the same. And pretty much these are the only forces. Perfect. Calculate the tension in the string. Okay, so let's have a look over here. If we really look inside this diagram, okay. Because the 7 kg is very heavy, the actual pulley is going to be, for the 7 kg, it's going to be accelerating down, whereas for the 3 kg, it's going to be accelerating up. And the acceleration is the same. It's in terms of magnitude, it's the same value. So just knowing that, what are we going to do? Well, using Newton's second law, force equals mass times acceleration, let's just take care of this one. Let's make an equation for this one. So, force, so pretty much net force equals mass times acceleration. And what's the net force in this case for the 7 kg one? Because we're taking acceleration down, we're going to take down as positive. So first we're going to add these together, and that will give us our net force. So 7g minus t equals your mass, which is 7, times your acceleration, which we don't know. So we'll write it as A. That's your first equation. Your second equation is example. Let's do this 3 kg one. Well, because we're taking acceleration up for the 3 kg, so the net force is going to be T minus 3g. So let's write it down. So T minus 3g equals mass times acceleration, which is 3a. Okay, and now we just calculate the tension. Well, first what I'll do is actually add those two. For example, if I add both of these equations, what we do is we get rid of that T. So we'll get 4g is equal to 10a, and hence acceleration is 2g over 5 meters per second. Now we got the acceleration, and we can just put the acceleration for this and so for t. So tension, it's going to be 7g minus 7a. Hence 7g minus 7, what's our a value? 2g over 5. Hence 7g minus 14g over 5, which we can simplify to be 35 minus 14g. Sorry, so you're supposed to be right g in here. Over 5. Hence your final answer is 21g over 5. Is that right? So yes. So 21g over 5, and that is your tension force. So that's your tension. Not too bad. You guys don't have to worry, especially for the students in the period of 2023. You guys are not going to be touching dynamics or mechanics. So yeah. So, but if you are doing physics, it's good to know how to solve these. Yeah. So question 2. Let A be this vector and B be this vector, where M is an element of all reals. Okay. So it says find the values of m such that the magnitude of the vector resolute of A parallel to B is equal to root 14. So let's actually visualize this. So we're saying, so this is vector A. Let's call this, let's call this O, and this is A. Hence this is vector A. And this over here is vector, so this is B. So hence this vector here is B. And breaking this down, this vector, and we'll call this C. And this vector over here from this to this is a vector resolute of A parallel to B. This is kind of a diagram that's used in your textbook, so you can easily. So what we're saying is find the value of m such that the magnitude of the vector resolute of A parallel to B is root 14. So this is the pretty much your vector resolute is OC. So this over here with this direction. Now, okay, and imagine we were trying to find the magnitude, so the length. Well, isn't the length of this the scalar resolute? Okay. So if I know that they've took the magnitude, it's just the scalar resolute. What they've done, in other words, this is what we're saying. We know that the vector resolute, so the magnitude of the vector resolute, so the vector resolute's A dot B over B squared dot B is actually just equal to the scalar resolute. There we go. Okay. Now, this is where the problem comes. We need to think, because we've taken the absolute value of it. So this is just a demonstration, for example. We could have, the direction to be right. So let's say m is positive. Or in other words, we could have actually, it could have been like this maybe. It could have been the opposite. Maybe A is this way. Oh, sorry, actually. A maybe could have been this way. So this is an A, and our direction goes this. This is your, vector resolute. So it's not, what we're saying, it's not just positive. It could also be negative. So we need to think about that. And we've taken that magnitude of it. So we've got rid of that negative, the direction. So that's what we needed to make sure. And that's what the thing is done. When we take the absolute value of the vector resolute, they've took, the positive or negative. So we need to be careful with that. So in other words, we actually have two values, and this is to kind of give you a hint. It said value or values. So we need to think, that's what we need to take the case in. So if I know that we are taking two cases, we can just let the vector resolute be plus or negative, because in other words, if you haven't known, to get rid of these absolute value, what we can make them as, to get rid of them normally, what we just do is we can put plus or negative. We can just replace them with plus or negative. And if I bring this plus or negative here, so A dot B, so your so plus or negative, that is actually equal to root 14. So your scalar resolute plus or negative, because we can have two cases, is equal to root 14. Okay, and now we can actually bring those plus or negative over here, so to make our life easier. So your actual scalar resolute, A dot B, is equal to plus or negative root 14. So that's, that's good to know. So let's take, root 14. So the first case, let's take root 14 as positive. So taking root 14. So let's find A dot B. So A dot B. Well, I want to kind of rub a lot of stuff out, actually. So because I've just explained, I'm just going to rub everything out here and just leave what I need. So to make kind of everything simpler. So if I just rub everything out and rewrite everything nicely. Okay, so A dot B over B, so your vector resolute, is equal to plus or negative root 14. So the first case is we're going to take the positive. So it's going to be, what's A dot B actually? A dot B is going to be, so what's 3 times 2, which is 6. Negative 2 times negative 1, which is plus 2. And what's m times 3, which is plus 3m. And that all is simplified to 8 plus 3m. And what's the magnitude of b? It's going to be the square root of 4 plus 1 plus 9. I've just took the square root of each of these values, which gives us root 14. Okay, so writing this, so 8 plus 3m is equal to root 14. And we're going to take the actual, we'll try positive 14 first. That's the first case. So 14. And let's solve that. Well, if we bring this, that's supposed to be root 14. So if I bring that 14 there, we just get 8 plus 3m is equal to 14. Hence 3m is equal to 6. Hence m is actually equal to 2. So we've got a positive value, which, okay, makes sense. So it means that the next m value should be a negative to check that's right. So let's try the next one, which we're taking negative 14. So we're saying 8 plus 3m over root 14 is equal to negative root 14, which, so 8 plus 3m is equal to negative 14. 3m, which we get negative 22, and m is equal to negative 22 over 3. Aha, we got a negative value, and that's great, and we can't, yeah, so your two values are just going to be m is equal to 2, and m is equal to negative 22 over 3. These are your two solutions. I hope that makes sense. So yeah, that's how you would do this. Question 3. Find sine of t given that t is this. So this plus this. Now, okay, that's all right. Well, because we know that these are just angles. Like, for example, this is an angle and this is an angle. And they're being added. So let's make our life easier and let's just call alpha an angle. Let's call this equal to that. So our cos is just cos inverse of 12 over 13. And let's call beta another angle, which is this over here. So we're saying tan inverse 3 over 4. Okay. So hence t is just alpha plus beta. And what we're doing is we're trying to find sine of t. So sine of t is just sine of alpha plus beta, which again, use your compound angle formula. So sine alpha plus beta is just if you look at your formula sheet, it's just sine alpha, cos beta, plus cos alpha sine beta. All right, and yeah, we just need to find those. Well, have a look at this. What is sine alpha? Well, if I just bring that cos to the right side, for example, let's come here. So if I bring that to the right side, so cos alpha is just 12 over 13. And the same for this one over here. So tan of beta is 3 over 4. What we can draw is draw two triangles for them. For example, if I draw a triangle for this, a right angle triangle. Well, it is an ugly triangle, I'm not going to lie, but let's just draw it like this. Maybe like this. There we go. Something like that. And it's a right angle triangle. And so because cos is adjacent over hypotenuse, so this is going to be your hypotenuse, and this is your alpha, and this is the 12. By symmetry, using Pythagoras theorem, I know for a fact this is a perfect triangle, so I know this is going to be 5. You can use Pythagoras theorem to find that out. Very easy. So I know that. What about beta? So if I again draw another triangle for this one. Okay, so this is beta. Let me write that down. And so it's tan is opposite over adjacent, so 3, 4, and I know this is also a perfect triangle, so this has to be a 5 there. And so we got these over here. So what is sine alpha? Well, we'll look at the alpha one over here. It's saying, we're saying opposite over hypotenuse, which is 5 over 13. Now, we don't have to worry about negative 5 of, like, the negative values, because they haven't told us any domain restrictions, so we just take them as positive. Cos beta, so we look at the beta here, and cos is, adjacent over hypotenuse, so it's going to be 4 over 5. Plus cos alpha, so cos is adjacent over hypotenuse, which is 12 over 13. And sine beta is going to be opposite over hypotenuse, which is 3 over 5. Okay, and there, we just have to simplify this now. So we can get rid of these. No need for these anymore. Yeah, just algebraically solve it. So I know these cancel out, so it's 4 over 13. That's great. So this will be 36. 13 times 5, what's that? 15, 65, so it'll be 65. In other words, we just need to simplify that. If I multiply 65 here, both sides, so 4 over 13, and 65 over here, 36 over 65, what do we get? Well, it goes 5 times in there, so 5 times 4 is 20. This goes 1, so plus 36, all divided by, because we use 65, we're going to divide it by 65, which is 56. 3, 4, 5. Yeah, 56 over 65. That's your answer for that one. Okay. All right. I hope that's right. We can actually put that down here. That's it. Nice. Next question. So question 4. Throughout this question, use an integer multiple of standard deviation in these calculations. The standard deviation of all scores of a particular test is this. Okay, so this here is your S value. From the results of a random sample of n students, a 95% confidence interval for the mean score for all students was calculated to be this. Calculate the mean score and the size of this random sample. Okay, I'm going to tell you right now, to find the mean score, it's the easiest one. This is how you do it. Imagine drawing a diagram, like a normal distribution curve. And let's draw a nice distribution curve. Now, this over here, well, the mean's going to be in the middle, of course. And these are going to be equally distant if a confidence interval. So we know that that's 51.7. And this one is 44.7. And these are equally distant from the mean. So because they are pretty much equally distant, it's the midpoint of these two values. So the mean is pretty much the midpoint of these two values. So that's easy. Just add these two and divide them by 2. That should give us the mean. So let's do that. So it'll be your mean is adding those two. So 51.7 plus 44.7 all divided by 2. And that's going to give us, so 96, so 96.4 divided by 2, so which is 48.2. Is that right? So it looks good, yeah. So 48.2, that's your mean now. Done. So we've got our mean. We can pretty much rub these off. That's our mean. So we can write your mean value is this over here. Whereas, the standard deviation, to calculate that, we have to kind of take our time. For example, okay, so we know that's let's, for example, look at this first one over here. So when we are writing your, it's in your formula sheet, to find the confidence interval, it's your mean value minus your integer value. For example, it's Z, but in this case, it's 1.96 for 95%, but we are using integer values, so that's 2. Multiplied by S over root n. And there's going to be X plus 2 S over root n. Now I'm just going to use this one over here, which is this one. I'm going to use that one, because we don't need 2, because we're just trying to find one variable anyway. So, do that, and okay. So, let's rub this off. So, it's going to be your mean, and your mean is, in this case, 48.2 minus 2, your S value, which is your standard deviation, which is 21, over root n, and we want to find n, the size of the sample, and that is all equal to 44.7. If I bring that 44.7 to this side, and so minus 44.7, and bring the other one to this side, so 21 over root n. So 48.2 minus 44.7. So if I add 3.3 to that, 4, 5, 6, 7, that's 48, and plus 2, 0.2, so 3.5, pretty much. Okay, so that's going to be 3.5, so, and 3.3 plus half, so 3.5 is just 3 plus half, which is 7 over 2. 7 over 2, which is 3.5. That's equal to 2 multiplied by 21 over root n. Okay, so I can go pretty much, so if I times both of them by half, we get 7 over 4 is equal to 21 over root n. And we can just take, that's 1, and this is 3, because 7 can go 3 times into it, so we can write this as 1 over 4 is equal to 3 over root n. Okay, and you do cross multiply, so that's going to be root n for a 12 equals 12. Hence, n is just 12 squared, which is 144. So n value is 144. Nice. Let's put all this over here. And let's write this down here. So your n value is 144, and this is your mean value. Done. Determine the size of another random sample for which the endpoints of a 95% confidence interval for the population mean of a particular test would be 1.0 either side of the sample. So 1.0 either side of the sample. So if I'm drawing a diagram here, let's represent this. For example, if I was drawing this over here, this is your mean again, and we're saying that the confidence interval is 1.0 either side. So it'll be 1 over confidence interval here is going to be x bar plus 1, and this one's going to be x bar minus 1. So this is your confidence interval here. That's what they're saying. And so say determine the size of the random sample. Okay, well, if I was trying okay, we did have a look at the formula. For example, if I'm looking at this one over here, it's just your sample, this one, your sample mean plus your integer value over s over root n, yes? And that should equal to x bar plus 1. That's equal to that. And okay, so if we got rid of those x bar, it's just 1 should be equal to 2 over s over root n. Pretty much. That is the formula that we're going to use, which is just half. It's equal to s over root n. And yeah, we can just calculate that. So s is the same, so standard deviation is the same, which is because it's saying the standard of all scores of a particular test is 21. So that's going to be 21 over root n, cross multiply, so that'll be root n to 21 times 2, which is 42. And then what's 42 squared? What's 42 squared? So 42, sorry, so that's 42, 2 times 2, 4, 8, 16, 7, 1, 1764. 1764. That's it. That's how, yeah, that's your answer. Hope that's right. Question 5. It says that evaluate this. Okay. Now, for a fact, I know this cannot be simplified in terms of cross multiply or it cannot be factorized nicely because it has that 5. There's no factors that give us 2x. So what we're going to do is, because it's 2x, I know for a fact it's much nicer to use differences of we're going to actually, make it into turning point. I think it'll be much nicer if we transform it into turning point, for example. So 1 over x squared plus 2x plus 5. And that's just going to be equal to x squared plus 2x plus 1 minus 1 plus 5. So that this part over here is now a beautiful perfect square, which is just going to be x plus 1 squared. And this one here is going to be plus 4. So that it can pretty much be simplified to that. And this is actually much nicer to deal with integration. So, okay. Well, so what we're going to do is we're going to rewrite this whole expression. So the integral 1, 2 root 3 minus 1. We'll bring this whole expression over here in terms of dx. Okay? And what I'm going to do is to make it much more simple, I'm looking at this and I'm like, okay. If I use the u substitution, let u is equal to x plus 1. Hence, dx is just going to be 1 over 1 du. So just du. And so let's use that. So we can just integrate. That can be 1 over. Now, u squared plus 4. We can write that as du. And these terminals are going to change. So if I put 2 root 3 minus 1, it's just going to be 2 root 3 actually. And 1 plus 1, which is just 2. Okay. Now, if you have a look at this, you should remember that when this doesn't this actually look familiar to so when we're integrating something that looks like a over u squared plus a squared du is equal to tan inverse of u over a. So this should be in your formula. So I'm just having a look at this, and doesn't that look very similar? But there's a problem. Our a value is 2. For example, we don't have 2 on top. So what I'm going to do is, let's think, okay. If I put a 2 on top, I need to compensate for that 2. So I'm going to multiply half constant in front. So imagine that half, it's just equal to 1. So that's good. And now we can actually nicely write it like that. So integrating this is going to be half integrate tan inverse u over 2 from 2 root 3 to 2. And now let's simplify. So first one is, if we put 2 root 3, it's just going to be root 3 minus tan. If I put 2, it'd just be 1. Okay, so now let's actually simplify this much further. So we're writing half. So tan root 3 is just pi on 3. So let's write this pi on 3 minus pi over 4, pretty much. And which is, so 4 pi minus 3 pi, which is just pi over 12, which is pi over 24. So it'll be pi over 24, pretty much. That's your answer. Nice. Great. Next question. Question 6. Let's see what it's saying. It's a different, can't believe. Given that y equals this is a solution to this differential equation, find the values of a and b, where a and b are real constant. This is very nice and easy. It's quite used in many exams. And what you just do is, if you, because it's saying d squared yx, like imagine deriving this, so dy dx, and then again, double deriving it to get d squared, and just kind of putting them all together as a nice expression like this, and then equate all the coefficients. So let's do that. So example, here we have y equals x minus 1 e to x. And let's try to find dy dx. So dy dx is, because we're just going to use the product rule, it's going to be x minus 1 to e to x plus e to x. The other one is just 1, so we'll leave it as that. Okay, and I'm just going to nicely simplify this. So 2e to x, x minus 1. That's it. So that is my dy dx, and let's find d squared yx. D squared, so it does your double derivative, is going to be deriving this. So again, we're using a product rule here, so let's do that. So it'll be 2e to x, 1 plus x minus 1 times 4e to x, and deriving this is just plus 2e to x. Okay, and I think we can simplify that. So that will be 4e to x plus 4e to x, x minus 1. Nice. So I'm just going to rub this and put that simplified expression right over there. Nicely. So we got that. And now, let's write it in this. So we're going to multiply a constant a to this one over here, your d squared. So let's do that. So if I was multiplying a for all of them, so 4a e to x plus 4a e to x, x minus 1. And then we're going to plus b to dy dx. So it'll be 2b e 2x x minus 1 plus b e 2x. And that's all equal to y, which y is x minus 1. Let me write it nicely. So e 2x x minus 1. Now I'm going to use equity pretty much for this. And we're going to equate them. So for all the expression that have e 2x x minus 1, for example, like this one over here, and this one over here, we can equate the coefficients. So the coefficients are, for this one, it's going to be 4a. Let's write that, 4a. For this one, it's going to be plus 2b. So 2b should equal the constant 1 in front of this. That's your first equation. Whereas the other one is because it's in terms of e2x. So e2x for this one and this one e2x. And here, imagine there's an imaginary e2x that's times by 0. So pretty much let's those coefficients. So it'll be 4a plus b is actually just equal to 0. And that's your second equation. And yes, we can calculate those values of a and b very nicely now. If I minus both sides, so 1 minus 2, the equation, we get b. So 2b minus b, which is just b. 1 minus 0, which is 1. So b is equal to 1. And I'm just going to sub b into this one to find a. So 4a equals -1. Hence a is just -1 over 4. Hence we got our values. So the a value is -1 over 4. And your b value is 1. Nice. Those are your solutions. Okay, so let's put those there. And those ones over here. Next question. Question 7. Find d dx 1 minus x. Okay, this is quite nice. Just because it's 2 marks, we do have to show some working out. You can easily do, multiply the power in front and that, but that's only going to give you 1 mark because you haven't showed your reasoning. If it was 1 mark, do that. But here it's 2 marks, so we're going to use the chain rule. So we're going to let u equal 1 minus x squared. And let with y. Y, hence, is just u to the power of half. Hence, u dash is just -2x. Y dash is half u minus half. And then multiply u dash times y dash, which gives us -u over, so my apologies, so if I multiply that, it's going to be actually -x over the square root of u. That's your dy dx in this case. Where u is what? So replacing u, it's the square root, and u we said was 1 minus x squared. So that whole expression is equal to -x 1 minus x squared. Nice. We've just used the chain rule here. Hence, so it means using this over here, find the length of a curve specified by this from 1 over 2 to root 3 over 2. Give your answers in k pi, where k is an element of all integers. Okay, so what I'm going to do is, well, to find the length, using your length formula, it's going to be, we're saying from half to root 3 over 2. And we know it's in this formula, so in your formula it should be written as 1 plus f dash of x all squared dx. This is to find a length for a curve. Well, in this case, our f of x, well, we'll call it, we'll write it as y actually. We want to write in the same notation, so let's call it y dash of x. Y dash of x. So what's our y dash of x? Y dash of x for this equation is, again, this equation is just the same as this equation over here. And imagine deriving it. It's just what we just got. -x over 1 minus x squared. Now, imagine squaring it. So, y dash of x all squared, which gives us x squared over 1 minus x squared. And then what we're going to do is we're going to 1 plus, so we're going to add 1 to it. So, y dash of x is equal to 1 plus x squared over 1 minus x squared. Okay. What I'm going to do is I'm going to bring this over here. And so we can rewrite this as 1 minus x squared plus x squared, all divided by 1 minus x squared. Now, these can actually cancel out. So hence, this whole expression can be written as 1 over 1 minus x squared. So let's write down in our formula. So half root 3 over 2 square root of just 1 over 1 minus x squared dx. Pretty much. So, I mean, we can easily square rooting of 1. We can rewrite this whole expression as, was the square root of 1 is just 1. So just 1 over the square root of 1 minus x squared dx. Aha, now this expression, if you look at your formula sheet, is to integrate that, it's just sine inverse. So length is going to be sine inverse of x, in this case, from root 3 over 2 to a half. Hence, we're saying sine inverse of root 3 over 2 minus sine inverse of a half is equal to your length. So your length is, this can be written as pi over 3 minus pi over 6, which is, so it's only 60 minus 30 degrees, so that's 30 degrees, which is pi over 6. So your hence answer is pi over 6. That's your answer. That is your length, actually. So your length overall is pi over 6 units. Nice. All right. So, I mean, yeah, that's nice. Not too bad for a question. For 2 marks, yeah. I mean, that's great. Let's move to the next question. Question 8. A circle in a complex plane is given by this relation. Okay, where Z is an element of all complex, sketch the circle on the arcgram diagram. Okay, what I love about this notation, okay, if you have a notation like this, example, I'll tell you what they mean. So we had Z, let's say, example, like minus A minus B equals some value C. Okay, this is what you're going to need to know when expressions are written in complex form like this. This value over here is what is the radius of the circle. This is the radius of the circle. This over here, this is supposed to be I here. This form is just, imagine that, what is like, if this is negative A, imagine taking the positive of it, so A. For example, if you had, imagine just solving it, like imagine just solving the inside. So Z, so it's just Z minus A minus BI equals 0, hence Z is just A plus BI. This over here, so A plus B, so AB is, this coordinate over here, AB, is the center of that circle. So for example, this one over here is just going to be, imagine this says negative A, just make a what's the, like, the difference? Just A. If this is negative B, make a positive B. So that is your coordinate. If it was positive, this would be negative A, negative B. So hope that's a good expression to write. Yeah, so this is your center of the circle, and this is your radius. That's all you're going to need. So just knowing that notation can help you a lot in this question. So okay. So what does that tell us? So now we know, so this over here, we have, the center is 1, 1 actually, in this case, and the radius is 2. Let's, okay, draw that. So 1, 1 is over here, and the radius of 2, so 1, 2, so here it's going to be a point, he's going to be a point, and he's going to be a point, 1, 2, so here also. And we're just going to draw a nice circle that passes through all these points. All right. Okay, perfect, just nice. Okay, that looks good. So this is a circle, nice. And yeah, that's the expression there. Next question. Write the equation of the circle in the form of this. Okay, now this over here is a nice expression. If you don't know, this is the coordinates. So A and B are your coordinates of the center, and C is so c squared is actually written as c squared normally. So in this case, it's just c. So your radius squared, pretty much. What's your radius, which is 2, and we square it, which is 4. Your c value here is 4. So let's write that. So in other words, in this equation, x, well, our coordinates are 1, 1, so it's going to be x minus 1 squared plus y minus 1 squared is equal to 2 squared, which is 4, which is, remember, your radius squared. Normally it's written as that. Alright, so we've got that, and we want to show that the gradient of the tangent can be expressed as it. So imagine, okay, let's actually expand this. So expand this, we get x squared plus 2x, sorry, minus 2x actually, minus 2x plus 1 plus y squared minus 2y plus 1 is all equal to 4. So we get x squared minus 2x plus y squared minus 2y equals 2. If I bring, add those 1 plus 1, 2, and bring it to the other sides 2. And, okay, we've done that. And now imagine deriving using implicit differentiation here. So if I, derive this in terms of x, it's just going to be 2x minus 2 plus 2y. Because we differentiate it in terms of y, we're going to have to multiply by dy dx. Also this one, so minus 2, we have to also multiply by dy dx. The derivative of a constant is 0. So we got this. Can you see how they all have a common factor of 2? Like, we can get rid of that 2, actually. So it's just going to be written as x minus 1. So plus y dy dx minus dy dx equals 0. So dy dx is going to be y minus 1 minus x, pretty much, and then divided that here, so y minus 1 dividing that, we get dy dx, pretty much. And that's the expression. And we've shown that. Done. Perfect. So the next question says, find the gradient of the tangent to the circle where x is equal to 2 in the first quadrant of the complex line. Okay, so we have our dy dx, we just need to find our y value, and we have our x value. To find out y value, well, we have this equation over here. And let's sub in that 2, x equals 2, so that's just 1 squared, so 1. So 1 plus y minus 1 squared equals 4. So y minus 1 is 3, y minus 1 plus or negative root 3, y is equal to 1 plus or negative root 3. Because we are talking in the first quadrant, it must be a positive value. Your y value must be positive. Hence, just y is equal to y plus root 3. Now we got our y value. Now let's sub them all to dy dx. So dy dx, your x value is 2, so 1 minus 2, divided by y, which is in this case 1 plus root 3 minus 1, which is a negative 1 over root 3. That's your dy dx there. 1 mark, nice and easy. Find the equations of all rays that are perpendicular to the circle in the form of this. So, okay, so what this ray is telling us, well, the center is 0, 0. So 0, 0 is the center, and alpha is an angle. So, okay, and we want to find all the equations that are perpendicular. Let's look at the circle, okay. So again, the ray here starts at 0, 0 because it's argument of z. And this ray can actually be pretty much anything. So where is this ray going to be perpendicular to 0? For example, here, we'll start from 0. Like, we'll start from 0, from the angle 0. And if we go, we're not seeing any perpendicular until we hit here. Can you see how here it's actually perpendicular? If you have a look at it over here, it's actually perpendicular. But if you, for example, if we try this one over here, let's say we tried here, this is not perpendicular. Have a look at that. That is actually not perpendicular. So I know for a fact that, okay, we just found that over here, it's nicely perpendicular. So that equation over here, which is, well, it's the midpoint of this. It's the midpoint of the thing. So it's pi over 4. The angle here is just pi over 4. It's 45 degrees. So our alpha for one of them, so we can say argument of z is pi over 4, and it is between, we need to make sure also that the argument is between negative pi to 2 pi. So that is good. So we got an actual perpendicular gradient there. There has to be probably more. Let's try some more. Nicely so. That's the center. Okay, so again, the rest starts from here. So we said we started, okay, we don't see any perpendicular, not here, not here. We saw one there. Still not perpendicular. Not here, not there, not there, not there, there. Let me just show it nicely here. Oh, that's... So, I don't... But here, yeah, here we do get a perpendicular gradient, like over here. If you have a look over here, nice actually. Let me draw this nicely. So if I just draw this nicely, if you look over here, so we did get a perpendicular here gradient. And if you go over here, we also get another perpendicular gradient over here. Have a look at that. This is also perpendicular, which is at an angle of, remember, because we're saying it's between negative pi, the 2 to pi, so it's going to be negative pi plus pi over 4, which is what? So negative pi plus pi over 4 is negative 4 pi plus pi. So so it would be negative 3 pi over 4. That's another ray. So argument of z is going to be negative 3 pi over 4, which is between those values. It's saying find the equation. I think there could be more. Let's try to look for more. Just trying to be 100% sure. Have I got all of them? Let's try. Look. Again, so if I started from here. So, not nice. Also, just want to make sure, double check. See, these are not perpendicular. They don't look perpendicular, so that's not good. Only until you here, that's perpendicular. Not perpendicular. Have a look at this. This is nowhere perpendicular. Just look at that here. It's not nice and perpendicular. So, here, not nice and perpendicular. It's not perpendicular. Only here. Yeah, only here and pretty much here. Those were the only two values that look like they were perpendicular. So, yeah. So, we'll write those as... yeah, these are your argument of z equals, and make sure they are between the argument of z. So the argument principle, which is negative pi to pi. Done. Question 9. Given that cot, so pretty much cot 2 theta is equal to a, show that it's equal to 10 squared theta plus 2 this and that. So I don't like how they use cot. So it's just cot is just 1 over 10, by the way. Make it nice and easy for yourself. Don't ever make it too difficult. So, well, let's use blue here. So we can rewrite this as 1 over 10 2 theta. And we can actually, and that's all equal to a. And we can, imagine reciprocating both sides. We just get 10 2 theta is 1 over a. Okay, and tan 2 theta, using your double angle formulas, is just equal to 2 tan theta 1 minus tan, so 1 minus tan squared theta should equal 1 over a. If I multiply that over here, we get 2 tan theta is 1 over a minus 1 over a tan squared theta. Okay, we're making some progress now. Let me just take that here and write that here. If I multiply both sides by a, we get 2 a tan theta 1 minus tan squared theta. So tan squared theta. And we want in this, so I'm going to bring this, both of these to the left. So it's going to be tan squared theta plus 2 a tan theta minus 1 equals 0. Yes, we've shown that it's there. Nice. Just using your double angle formulas here. Show that tan theta is equal to this. Okay, I mean, if we know, in this case, we're using this equation over here. If we know, let me use a different color. If we know that if we actually let tan theta be u. So using this expression, this is going to be u squared plus 2au minus 1 equals 0. So it is in terms of a, so we're going to, probably the best would be using your quadratic formula. So let's do that. So it's going to be negative b, so it'll be negative 2a plus or negative b squared. So it'll be 4a squared minus 4, a is 1, and c is negative 1. All over 2a, which is just 2, which is negative 2a plus or negative. We can take 4 out from there, so it'll be just 2 inside the square root, which gives us a squared plus 1 all over 2. Now we can get, we can get rid of a 2 because of the common factor. We can rewrite this as negative a plus or negative square root of a squared plus 1. That's pretty much it. So yeah, just using a quadratic formula, and that's what we get. Nice and easy. This was not too bad. So we've shown that. And remember, that's equal to u. And remember, u is what? Tan theta. So we can rewrite this as just tan theta is equal to that expression. Done. 1 mark. Easy. And hence, so it means using this expression over here, show that tan pi over 12 is equal to 2 minus root 3, given that cot 2 theta equals root 3, where theta is between 0 to pi. Okay. For example, have a look at this. Cot 2 theta is equal to a. Well, in this case, our a value is root 3. Let's write that down, root 3. But we want to find tan pi over 12. So if we have this, so cot pi, so 2 times, it's 2 times pi over 12, so it'll be pi over 6. It should equal to a. That's what it's saying. So cot, using this expression over here, we've already given us the a value. I just want to double check if that's true. So if we sub theta, because remember theta is pi over 12, so 2 times pi over 12 is pi over 6. So it's 1, so which is 1 over, what's tan pi over 6? It's 1 over root 3, which is equal to root 3. Yes, so pretty much, yes, that's your a value. That's great. So if that's, so we now have that theta, and can just pretty much use this expression over here to calculate tan of pi over 12. So negative a, well, our a value is root 3 now. So root 3 plus or negative, so root 3 squared, which is just 3 plus 1, which is 2. Square root of 2 is just 2. So square root of 4 is 2. So that. Hence, we get 2 values. But be careful. Theta is between 0 to pi, so we're only going to take the positive value. So we write it as 2 minus root 3. Done. And yeah, that should be how you do that. Have we done anything? I think because it's 1 mark, we do want to kind of show that. Look, I mean, I don't think this is quite enough to show an exam that you do understand. So I think what we would do normally is, you would have to write to tan pi over 12 is just equal to negative a. So you might write negative root 3 plus or negative root 3 squared plus 1. So you want to show that whole thing over here. That's it. Find the gradient of the tangent to the curve of y equals tan theta, add this. Okay, that's nice and easy. So that's going to be, what's dy dx of tan theta? It's just going to be secant squared theta. And we're just going to sub in pi over 12. So dy dx, or x, so theta, pi over 12, is just going to be, because it's secant, we can rewrite it as 1 over cos, actually. Just write it as 1 over cos squared pi over 12. Okay, and we don't know what that is actually. Cos squared pi over 12. But guess what? We have this over here. So, oops. We have this. So we can actually just make a right angled triangle. And say, this over here is pi over 12. Imagine this is divided by 1. So this is your tan is opposite over adjacent. So 2 minus root 3, your adjacent's 1. And imagine just finding the your hypotenuse. Imagine using Pythagoras theorem here. So if I was using Pythagoras theorem, it's going to be the square root of 1 squared, which is 1, plus 2 minus root 3 squared, which is 1. It's going to be 2 minus root 3, be 4, minus 2 root, so sorry, minus 4 root 3 plus 3, which is 7 minus 4 root 3. And imagine adding 1 to it from here. It's going to be overall 8 minus 4 root 3, pretty much. Yeah, that's it. So we've got that, and we can write this over here. That is your hypotenuse. Just use Pythagoras theorem for that one. So the question's telling us, so hence we can say that cos of pi over 12 is what? It's adjacent over hypotenuse, so it's 1 over the square root of 8 minus 4 over 3. And imagine squaring it. In this case, it's just going to be, so if we square that, we get 1 over, you'll get rid of that square root, so it'll be just 8 minus 4 over root 3. And we're then taking the reciprocal. So taking that reciprocal, it's just going to be 8 minus 4 over 3. Nice. So pretty much that's how I would do that. So I would just bring this over here. I'll write that down here. That is just all equal to 8 minus 4 over root 3. That is your final answer. All right. I'm going to get rid of this. All right, and bring this over here. That's it. This is the last question. Yes. So, C, a solid revolution is formed by rotating the region between the graph of y equals tan theta. So imagine this over here is tan. Let's draw a tan. So tan looks like this. Let's say like a tan. And the horizontal axis and the line pi over 12 and pi over 3. Let's say pi over 12 is here and pi over 3 is over here. And it's rotated about along the horizontal axis, which is the x-axis. So imagine it's over here if it was. So we're rotating this like this. It's being rotated. Find the volume. Very nice and easy. So volume is going to be pi, the integral of where we're starting, which we're starting at pi over 12 to pi over 3. And where are we rotating? Well, we're rotating along the x-axis, which we write dx. Because we're rotating along the x-axis, so we write dx. Hence, the inside has to be y squared, which is, in term, y is this, so it's just going to be tan squared theta. Okay? And that's what we're going to solve, pretty much. Let's delete this. Now, okay, tan squared theta. Well, we can rewrite that as 1 plus. Remember this expression? It's written in your formula sheet. So tan x is equal to secant squared x. Now, here, I can replace tan with what secant squared x minus 1. And it should make integration easier. So for, your volume is just pi, integral, pi over 12, pi on 3, which will be secant squared theta minus 1 d theta. Okay. I'm supposed to write that as the d. Why do I write dx? It's supposed to be d theta. Okay. Now we know that this over here, the integral of secant squared theta is just it's just tan theta. So we can write that. That's going to be nice and easy. So volume is just pi. So that'll be just tan theta minus x. So actually minus theta. We have to get it in theta form. Pi over 3, pi over 12. And let's sub those in. So pi So if I sub in pi over 3, so it'll be... Okay, so tan pi over 3 is just root 3 minus pi over 3 minus, what's tan pi over 12? Tan pi over 12 is over here. It's just 2 minus root 3. So 2 minus root 3 minus pi over 12. That. So we need to simplify this. Pi is just going to be root 3 minus pi over 3 minus 2 plus 2 root 3 plus pi over 12. Is that right? Have I made a mistake? Nope, looks good. So pi is 2 root 3 minus 2. What's minus pi over 3 plus pi over 12? Which is minus 4 pi plus pi over 12. Which is negative 3 pi over 12. Which is negative pi over 4. So negative pi over 4. That simplifies to 3, 6, 9, 12. Yeah. So pretty much that's it. Yeah. We write unit cubed because we're dealing with volume. That's it. I think that's the answer. I hope that's right. I will be checking out my answers after this video. And if I get any questions wrong, I will make sure to write them in the description. Yeah. I hope you enjoyed this video and learned something through this video. I hope it was very good. If you guys want more videos like this, please make sure to like and subscribe and share this video with your friends. It's a great pleasure doing these videos. They're quite fun. And I hope they are very helpful for you guys who are doing VCE. And good luck with your VCE studies. Have a great day. Bye-bye.